Hello everyone. In video number 7, I introduced the concept of factors and multiples. On this video, I want to talk about two related concepts: least common multiples and greatest common factors. These concepts will be used when we talk about fractions. On video number 7, I mentioned that factors and multiples are applicable to all integers, but most often, we only consider the domain of the counting numbers. For this discussion, we're going to stick with the domain of the counting numbers. Also on that video, I discussed prime factoring. Prime factoring will be used for both the least common multiple and greatest common factor. So, if you're unfamiliar with the concept of prime factoring, please review video number 7. Let's start with least common multiples. This is normally abbreviated as LCM. Let's consider two counting numbers, say 3 and 4. Now let's write the multiples of both numbers. Remember that the multiples keep going to infinity, so I'll just write the first several. If you look at these two series of multiples, you will notice that they share common numbers. In this case, the numbers they share are 12, 24, and 36. These are called common multiples of 3 and 4. And the smallest of them, 12, is called the least common multiple of 3 and 4. That's it in a nutshell.
This is quite simple, young man.
Yes, the name is scarier than the idea. Let's try a few more to make sure we understand. What is the least common multiple of 9 and 12? First, let's start by writing down the multiples of 9 and 12 like this. I see three numbers that are common to these series: 36, 72, and 108. The least of these numbers is 36, which is therefore the least common multiple. What is the least common multiple of 4, 5, and 6? Again, let's start by writing the multiples of 4, 5, and 6. This time I only see one common multiple, 60. It is the least common multiple. You can see that the process of writing out the string of multiples for each number until you find a common number will always work. Many of you can probably do numbers like this in your heads, and if so, that's perfectly fine. But I think you can see that if you're trying to come up with the least common multiple for several numbers, or if the numbers are somewhat ugly, then this way of solving problems can get unwieldy, time-consuming, and mistake-prone. There is another way of finding least common multiples involving prime factoring. Let's consider the numbers 6, 8, and 9. First, let's determine the prime factors for each of these numbers. For 6, it is 2 and 3. For 8, it is 2 times 2 times 2, or 2 cubed. For 9, it is 3 times 3, or 3 squared. In order to find the least common multiple, we take all of the prime numbers that we have found and select the highest power that occurs for each of those prime numbers. Then we multiply those values together. There are two prime numbers. The first is 2, and the highest power of 2 we have is 2 cubed. The second prime number is 3, and the highest power that occurs is 3 squared. We take those two numbers, 2 cubed and 3 squared, and multiply them together. 2 cubed equals 8, 3 squared equals 9, 8 times 9 is 72. The least common multiple of 6, 8, and 9 is 72. Let's try another problem. What is the least common multiple of 12, 14, and 15? I guarantee you that writing out the multiples of these numbers to look for common multiples is going to take a lot of time and is an error-prone process. So let's use prime factoring. The prime factors of 12 are 2 squared times 3. The prime factors of 14 are 2 and 7. The prime factors of 15 are 3 and 5. So we have found a total of 4 prime numbers, 2, 3, 5, and 7. For each prime number, we take the highest power that appears from factoring these numbers. For 2, it is 2 squared, which is equal to 4. For 3, 5, and 7, it is simply those numbers, to the first power technically. So we multiply 4 times 3 times 5 times 7. The answer is 420. It is the least common multiple. Let's do one more problem. What is the least common multiple of 18, 21, and 28? Pause this video and try to figure this out yourself. And when you think you have the answer, then resume the video. Let's see how you did. First, we perform the prime factoring of each of these numbers. For 18, it is 2 times 3 squared. For 21, it is 3 times 7. For 28, it is 2 squared times 7. We have a total of 3 prime numbers, 2, 3, and 7. Next, find the highest power that occurs for each of them. The highest power of 2 is 2 squared. The highest power of 3 is 3 squared. The highest power of 7 is simply 7. The least common multiple of 18, 21, and 28 is 2 squared times 3 squared times 7, which is 252. How did you do?
Nailed it!
Great. If you had trouble, then review the examples again. You can also review video number 7, which discusses prime factoring. Don't give up. So let's tackle the concept of greatest common factor. The abbreviation for this is GCF. Let's pick two numbers, say 12 and 20. Now let's consider all of the factors of 12 and 20. For 12, the factors are 1, 2, 3, 4, 6, and 12. For 20, the factors are 1, 2, 4, 5, 10, and 20. When I take a look at these two lists of factors, I notice that the factors 1, 2, and 4 are common to both lists. The greatest, that is the largest of these common factors, is 4. Hence 4 is the greatest common factor of 12 and 20. That's it. It's a straightforward concept, but sometimes doing the arithmetic can cause us problems. Let's try another example. What is the greatest common factor of 18 and 27? The factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 27 are 1, 3, 9, and 27. The common factors are 1, 3, and 9. The greatest of these is 9, so it is the greatest common factor of 18 and 27. As I said for least common multiples, a lot of you can do problems like this in your head or very simply by pencil and paper. That is absolutely fine. But it can get difficult and time-consuming as things get more complex. When the numbers become difficult to work with, we can often more quickly and reliably find the greatest common factor using prime factoring. Let's try that. What is the greatest common factor of 320 and 360? Writing out the list of factors for both of these numbers and finding the largest is a possibility, but it isn't the only way to proceed. Let's try prime factoring. If we do the prime factoring of 320, we get 2 to the 6th power times 5. For 360, we get 2 cubed times 3 squared times 5. To determine the greatest common factor, we are going to select the prime number factors that both numbers have in common and take the lowest power that occurs of those prime numbers. We then multiply those numbers together. Both 320 and 360 have 2 and 5 in common. The lowest power of 2 is 2 cubed. The lowest power of 5 is simply 5. We multiply those two values together. 2 cubed is 8, times 5 is 40. The greatest common factor of 320 and 360 is 40. Let's try one more problem. Again, pause the video and try this on your own. When you think you have the right answer, then resume the video. What is the greatest common factor of 288, 360, and 432? Pause the video now and give it a try. Let's work this out. First, find the prime factoring for each of the numbers. The prime factoring of 288 is 2 to the 5th power times 3 squared. The prime factoring for 360 is 2 to the 3rd power times 3 squared times 5. The prime factoring for 432 is 2 to the 4th power times 3 cubed. Step 2 is to find the prime number factors that these three numbers have in common, and then take the lowest power that each of those prime numbers occurs. The common prime numbers are 2 and 3. The lowest power of 2 is 2 cubed. The lowest power of 3 is 3 squared. The last step is to multiply the factors that we found together. 2 cubed is 8, and 3 squared is 9. 8 times 9 is 72. The greatest common factor of 288, 360, and 432 is 72. Did you get that right?
Hot diggity, you bet.
Great. The most common mistake people make in determining the least common multiple and greatest common factor is that they get confused with the prime factoring processes, which are somewhat similar. Let's review. In order to find the least common multiple, we find the prime factors and then take all of the prime numbers we found to the highest power which we found in the prime factoring. We multiply those prime numbers together. For the greatest common factor, we again go through the prime factoring process, but this time take only the prime numbers that are common to all the numbers, and then take the lowest power that we find. Again, we multiply those prime numbers together. With a little practice, you will get used to the processes and should no longer be confused. We use the least common multiple in order to add or subtract fractions. We use the greatest common factor in order to simplify fractions. So now we are ready to tackle fractions in the next video. You've made it through another math video. Each time you make a sincere effort, your math abilities improve. Keep it up. Have a nice day, everyone.
We hope to see you at Veterans Upward Bound very soon and recommend a friend.